Good afternoon. Let's get started. First, an announcement about next week's talk. The talk next week is actually a panel discussion on carbon capture and storage, looking at where the technology stands, but also what's happening on the business side. We'll have three panelists, two of them from UT. Sue Hovorka, who is a senior research scientist at the Bureau of Economic Geology at UT. Professor Gary Rochelle, who is a professor in the Chemical Engineering Department, and Doug Heggie, who is commercial leader of the gasification business at GE. Our speaker today is Eric Bradley. Eric is Vice President of Strategy at Gdf Suez, North America. He's responsible for setting business strategies and priorities for GDF's gas and power interests in the United States, Canada, and Mexico. Prior to GDF, Eric was with Reliant Energy, where he held a number of leadership positions. Eric worked earlier in his career as a management consultant in the power generation, petrochemicals, and petroleum industry, worked with McKinsey and other very large firms. He holds a bachelor's and master's degree in mechanical engineering and an MBA from the Wharton School of Business. He's going to talk to us on gas power nexus, a closer look at the gas value chain in power production. Please join me in welcoming Eric.
Thank you. Thank you. Can everybody hear me? Excellent. Just a show of hands, I want to get a sense of the audience. Everybody here is graduate students, or do we have some undergrads as well? Undergrad? Okay. Engineering? Public policy, I think that was the other one. Law? Okay. Any other majors I've missed? I'm sorry? Energy and earth resources. Okay, great. All right, well, it's a good mix. Well, thank you for having me here. I actually do have a connection to the school, even though I didn't go here. My brother went to UT, got his MBA here back in the late 90s, so he is excited that I'm up here and hopes that the football team does better the next game around. I know you guys had a tough week last week. Anyway. All right, so I'm going to try and keep this to 40 minutes. We have a lot of slides, but I'll try and keep myself to the 40 minutes, go through an overview of Gdf Suez for those of you who don't know the company, talk about why I think this is a very exciting time for participants in the energy business, and for those of you that might be considering a career in energy, why it's an exciting time, and then how our company in North America is participating in gas and power development. So our company is, we're actually 175 years old, if you go all the way back to the predecessor companies, and the Suez is actually Suez Canal. So the predecessor to our company, we're French-based. We actually helped develop the Suez Canal, industrial routes, and through a series of mergers and acquisitions in the last 30 years have actually made our way into the power and the gas businesses. So across the world, one of our big segments is electricity generation. We consider ourselves a little bit of bragging rights here in some of these figures. I took them from our corporate department, but we're the #1 independent power producer. You might hear the word IPP, stands for independent power producer, so we're privately run. We're not owned by the state. We're not a state entity. #1 producer of non-nuclear electricity around the world, 118 gigawatts of power, and to put that into perspective, the United States is about 1,000 gigawatts, so we're roughly around the world. We generate the equivalent of what 10% of the U.S. has in terms of capacity. And then right now we're building about 10% of what we currently have, we're building around the world. Big hydro plants in Brazil, no nuclears right now, gas plants, gas-fired power plants, a little bit of coal in Indonesia, but we're all over the world. Very large desalination and water projects in the Middle East. So that's one of our business lines. The other area that we're pretty big in is in natural gas. We're the #2 purchaser of natural gas in Europe, given our European roots. The #3 importer of LNG. LNG is liquefied natural gas. #1 natural gas transmission and distribution network in Europe. And then we have a supply portfolio of 1,260 terawatt hours. So that's a gas number equivalent to 115 billion cubic meters. So that's a lot of gas. The other area that we're in is in services, and so this would be managing buildings like this, the energy services of the buildings, keeping the costs down, getting the efficiency up, managing the water. We actually own some facilities up in New Jersey, some water treatment facilities and municipal water areas. And then we also have district heating and cooling, mostly in continental Europe. So a brief overview of the company. If you look at where we participate in the value chain, what I've laid out here is starting with natural gas exploration and production. So these are the rigs. We're involved in the gas side of it, not on the oil side. In fact, when we find oil, we're not sure what to do with it because we tend to stay purely on the gas side. So we have the rigs, and then we're also in supplying infrastructure. So once the gas gets produced and brought on shore, it has to be cleaned and treated and then shipped to the markets, either for power generation or for use in residences and businesses. So we're involved in shipping. Those two green vessels you see there are LNG tankers. They hold about 3 trillion BTUs of energy, and to put that in dollar amounts at current energy prices in Japan, that's about it's about $60 million worth of product that's shipped around the world, and we're lifting it out of the ground at about a fraction of that number. Some of the pictures at the bottom are just gas infrastructure. These are large, high-pressure pipelines that deliver gas over thousands of miles to take it from onshore facilities into where it's consumed. And then a very important part of what we do, we don't trade. It says trading and portfolio management. Well, what we do is, since we're a physical player, we physically deliver gas, we physically generate power of various sources, we take coal and other primary forms of energy. We have to manage the risks, the physical risks of getting the material to the power plants, and also the price risk, taking the commodity risk. So we have a very big activity around the world to manage the price and the volume risks for our business. And then, of course, in the area that I'm involved in, power generation, and I'll go through a little bit some of the technologies, and I think one of the challenges right now for the United States and actually for other parts of the world is, what is the right technology to build? And I think a public policy question is, there's one dominant technology now. How do you think about energy security when you rely on one fuel? And as we saw with Japan and Fukushima, they've relied on one fuel predominantly, and it got them into trouble. The U.S. could go down to that same route when we get to gas. So we'll talk a little bit about that. But power generation, that picture there with the striped stacks, it's a combined cycle power generation plant in the Middle East, nuclear plant with the steam coming out of the stack, solar, and a wind facility, and then a big hydro facility down in Brazil. These hydro facilities are massive. They're 2,000 to 3,000 megawatts. It's about 2 to 3 times what a typical power plant is. And then getting to where we will see the power is the distribution of the power. This is a switch center. And then in the sales and the energy services, these are actually some pictures in Europe of managing the energy distribution into buildings. So a quick snapshot of where we participate. A couple of factoids on the company. We talked about the 118 gigawatts of capacity. We're primarily natural gas. We're actually very proud of that. We consider ourselves fairly carbon light. We do have coal, of course. Coal is important for stability in the grid, but mostly natural gas, and have quite a bit of renewables in production and being built. Most of our earnings, almost 45% of our earnings is in Europe, North America, and actually Texas is a very important part of our business. It's about 10% of our worldwide revenues. So within North America, we have our energy segment, so power generation and LNG. It's a picture of a ship, LNG vessel, coming into New York Harbor. We have, and I'll actually show this on another page, but we have a receiving facility. We take LNG into Everett, Massachusetts, which is right outside of Boston. It's actually one of the only operating LNG facilities right now that's actually taking gas into the country, and we'll talk about that in a minute as to why that is. Also, environment is another segment that we operate here in the U.S. and in Canada. We do water treatment as well as water distribution. And then in the energy services, this is the building management, facilities management. So it's North America is a very, even though we have French-based roots, European roots, North America is a very important region for the group. I think one of the things that we're always able to tell our colleagues back in Europe that's great about the U.S. is there really is a lot of innovation occurring in this country, and we rely, I think the group relies on the innovation in this country to learn how to deploy technologies and capabilities in other parts of the world. So it's a real advantage for the group being in this part of the world. 6,700 employees. Here in Texas, we have about 5 power plants, and we have about 600 employees that are, most of them are in the Houston area, but there are salespeople scattered around the states, and of course, personnel within the power plants. And we generate about $6 billion in revenue, so a fairly big player. Here's a map of the United States. All these little black dots represent locations of power plants. The black dots are the power plants. The red dots are just business offices, and these little lines in Mexico are the gas transmission facilities. And we span the entire value chain from LNG shipping, which were the pictures I was showing earlier, all the way out to selling power in competitive regions. So Austin is not part of the competitive region of Texas, so we don't sell power here. If it ever does, you'll see us here, probably trying to sell to the University of Texas, and all steps in between. I mentioned the Everett, Massachusetts terminal. This is a picture of the cryogenic terminal with the ship bringing it in. Actually, it's a picture of Boston in the background. We bring this gas in from Trinidad and Tobago, and actually some real nice spots from the Middle East. The gas comes into New England, and in some cases we're actually able to divert the gas and to bring it over to markets in Asia. It's actually very, very profitable, and I'll get into that in a minute, but that's a big part of our business is actually diverting cargoes away when we can find gas within the U.S. to serve our customers. We also have gas distribution down in Mexico. We serve 200,000 customers in that country. We have a picture here of one of our guys managing, it's a control valve around a transmission and compression facility. And then some pictures of some power plants. This is actually, the power plant to the left is actually about 100 miles from here. It's our Midlothian plant here in Texas. And then we have some water, hydro up in New England, and some renewables up in Canada, and I'll talk to you a bit. Most of the renewables development that we're doing in North America is in Canada, and specifically in Ontario, and I'll tell you why in a little bit. And of course, we have our trading operations to manage the physical and the financial flows of the power and the gas. So I think one of the things that makes us very unique, if you look at our competitors in the U.S., is that we're the only player that has LNG, and LNG in New England. New England is a unique market, and I have a map that I'm going to show in a minute, but it's a unique market in that it's very difficult to get gas up into that market. So it's a premium market. It's difficult to bring additional infrastructure in. A lot of people don't want pipelines to be put in their backyard, and it's very expensive to build pipes. So we've actually been able to take advantage of having a fairly, I'd call it an island really within the United States for bringing gas in. And some of these pictures are showing, here is a truck that is actually loading gas off of the terminal. This is a truck that will actually ship the gas. There are some customers actually in New England right now that use LNG in their facilities, even in some of their trucks. We're going to talk about that in a minute, but we actually have one customer, Enviro Express, that do waste treating. They pick up trash and other things and do environmental treatment, but all of their trucks run on LNG, and they've actually been doing that for quite a while. So this is a truck that's actually picking up that LNG and then bringing it down to their local distribution center in Connecticut. There's a picture of one of the LNG trucks, and then some pictures of our LNG tankers. I wanted to talk a little bit, the topic was around gas power nexus. When we think of gas power nexus, what do we think about that for New England? And I picked New England because one of the things that we think is very important in this industry, you're managing commodity and you're managing supply risk every day, and it can put companies out of business very quickly. And for those of you that have followed bankruptcies in the last 10 years. There were a lot of companies that didn't get it right, and they went through bankruptcy. And it's like one of the things that we really pride ourselves on. But in New England, what we call our business is a system play. And by that is we have the gas LNG terminal and business that I talked about. We have our power generation facilities, and we do electricity retailing. This is where we're selling competitively within the market. We take advantage of the physical and the financial connections between those three segments to optimize the business. So we actually think we have a better business. We can run a better business by having those together. So what do I mean by that? If you look within the gas and the LNG business and you look at our power generation business, our power generators, the gas-fired power generators, have a choice of buying gas on the pipeline grid. So they'll bid into a wholesale market and they'll say, I'm going to sell power for a certain amount. And they also have to get nomination of pipeline capacity. If they can't get that gas, or for some reason there's an upset, they actually have a backstop, and the backstop is our LNG business, our LNG gas. So we have a physical backstop, and we can actually self-procure gas, which gives us an advantage. And it also gives us a physical diversification that we wouldn't get if we were just playing in power generation. One of the other things that's a benefit is, and this actually was critical a couple of years ago through the financial crisis, was posting collateral. We can actually net out the financial obligations that we have between the generation business and the gas business when we want to hedge those out financially. By doing that, by being able to net those positions out, we don't have to post collateral. So what does that mean? Well, think of it as you have a credit card and you want to borrow something, and the merchant says, well, I need your credit card. I'm going to put $1,000 on your credit card. I'm going to charge you a little bit of interest while I do that. That costs the company money. And so when we're spending $10 million, $100 million on our credit card, we can actually avoid a lot of that and avoid the cash drain that requires. The other benefit is that when you're buying gas and when you're selling gas, there's always a difference in price. Somebody's going to sell it a little bit higher than they want to buy it for. We can avoid that, so you have a little bit of savings there. You can do the same thing when it comes to going from power generation to electricity retailing. We can self-procure some of the products. Electricity retailing is actually very complex. You might think just running the lights, it's just a commodity. You just turn the power plant on and run it. It's actually far more complex than that. You have to buy blocks of power. You have to estimate the load. How is this building going to use power over a 24-hour period? And what happens if the weather changes? How do you manage for that contingency? So there's a lot of planning that goes behind the scenes to figure out what do I think my customer's going to use, and then what kind of products from the power plants, the different power plants, do I need to meet the loads of the customer? And in some cases, some of these products are very difficult to get. There's not that many power plants out there that provide peaking power or some of the other things that you have to buy to run your business, and that's where self-procurement comes in. Same benefit again on collateral postings. Retailers don't have to post. They don't have to put money on their credit card, and the generator doesn't have to do the same as well. So you get a lot of benefit out of that. So the overall benefit for the company is we have earnings diversification. We're actually able to make sure that some earnings are going up while others are going down. The overall net benefit is a more stable business. So I want to spend a little bit of time going through why I think the industry and North America is really going through a fundamental transformation. I really, really mean that. I know you've heard about the word game-changing with shale oil and shale gas, but it is really changing the industry, and I think it's, this happened back in 2008, 2009. I think a lot of people are starting to realize what is happening. But if you look at from our perspective as a company in the gas and power business in North America, one of the things we had to think about, or some of the issues we had to think about, is where is renewables policy going? The government, we're going to go through an election in a couple of weeks. Congress has to figure out, hopefully they're going to figure out this debt issue. What happens to the production tax credits? There are credits available for people who develop wind and solar. Where do those go? Do they go away? Do they get changed? Do they get extended? So it's a big question mark. The other thing that's happening is for existing power plants, and this affects Texas as in many other states, is there are a series of regulations that actually go all the way back to even before the 90s, that are actually going into place now. These are regulations around emissions of sulfur dioxide, NOx, mercury, all these nasty things that are in the air. These emissions are going to be regulated in the next couple of years, and so the result is power plants, and mostly coal power plants, are going to have to figure out, how do I cut those emissions down? And it usually involves a lot of investment to make the power plants clean. Gas and power infrastructure, I'm going to show you a map with the shale gas. What's happened, there's been a complete reorientation of gas flows. It's a huge deal for the U.S. Talked a little bit about the fiscal path, but I think the big story and why I made this oval big, shale gas, shale oil, it's huge. I have a graphic here. I'm calling it the emerging reorientation of gas and oil flows in North America. If you look back to, or just look articles back in 2006, there was a belief that we were running out of oil, we were running out of gas. LNG was something that everybody was trying to import. Our terminal is the only one that's importing it now. Now we see everybody's trying to export. Everybody's trying to export gas out of the country. And we also think the same thing's going to happen with oil. I think the story is just unraveling with oil, but I think some of the Bakken developments, if you heard about North Dakota and all the things going on there, I think we're going to find in a couple of years we're awash in oil as well. And it's amazing, some of these things that are going on. What do you do with this oil? And could the U.S. be energy independent, or North America energy independent in 10 to 15 years? For us as a company, what this also means is we have some opportunities to grow our business and do it in a way that we think is more environmentally sustainable than an oil-based economy. So in the U.S., there's the fuel switching and the power generation. There's a lot of coal plants that are actually shutting down, and a lot of natural gas-fired power plants that were running at part load that are starting to ramp up more. There's also the opportunity to take some of these liquid petroleum products, fuel oil. It's not really used here as much in Texas. It's very big in the Northeast, and actually convert that to natural gas. And then I've got a short discussion on using natural gas and liquid natural gas in transportation. That's a big opportunity that we're looking at as well. And then for our neighbor to the south in Mexico, Mexico's connected to the U.S. by gas. And so they're getting access to our gas, and they're also looking at building gas-fired power plants. So it's a huge opportunity for the Mexican economy, that they're able to come in, shut down a lot of their coal-fired power plants, bring in natural gas, and have a cleaner economy, and actually a lower-cost economy for their consumers. The other topic is decarbonization of the generation fleet, with the EPA rules coming in. About roughly a third of U.S. power generation capacity is coal. We think, and there's some other reports out there, that anywhere from 10 to 20% of that capacity could actually shut down in the next 10 years. It's pretty significant. We don't think Texas is going to get hit as hard, but some areas in the southeast we see some significant retirements. And then I think the big one for renewables policy is, when you look at what has happened with shale gas, and I'm going to show a graph later about what it's done to pricing, it actually makes it very difficult for, if your goal is to not only have clean energy, but also competitively priced energy for consumers and for businesses, it's very difficult to do that with renewables. And the current environment with shale gas, and possibly the lack of these tax credits, it's going to make it very difficult to continue building renewables without the subsidies. So I wanted to talk about the reorientation of the gas flows. What all this spaghetti on the chart shows, the blue lines are natural gas transmission lines. We have lines that run from, most of the production historically has been in the Gulf of Mexico and Texas and Louisiana. A lot of the gas traditionally gets shipped to the Northeast. About a third of the country lives up in this area. There's also this little region up here is what is called Marcellus. You might have heard about that. There's gas pipelines there. There's also gas pipelines from the Rocky Mountain area that have been built very recently to bring gas into the Northeast. So what we've been seeing is from the Gulf Coast up to the Northeast, from the Rocky Mountains to the Midwest, that's the traditional gas flows. What we're finding is happening is, if you look at this new field called Marcellus, Marcellus is roughly 15% of U.S. gas consumption right now, just a single region, roughly 15%. It's looking to find a home. And what it's doing is it's making its way to New York and New Jersey and very dense markets, a lot of fuel switching, and it's also looking to find its way south where there's a lot of coal plants and the opportunity to turn a lot of coal plants into gas plants. The other thing it's doing, bad for Canada, because a lot of gas, I failed to mention, there's actually pipelines that come into the U.S. from Canada. Canada has actually been one of our major suppliers of natural gas. And what we think is going to happen is Canada gets backed out. So Canada is looking to export LNG to Asia. So there's a lot of work underway to figure out, can they get gas out of Asia to Asia. The problem is, to the right of that arrow is, of course, the Rocky Mountains, very pristine area, very rugged area. How do you run a pipeline through that into a channel to build in a very remote area to ship the gas out? So they have their challenges cut out for them. The other thing that's going on is, I mentioned the pipelines that were built from the Rocky Mountains. Those were completed just a couple of years ago. There's a company called Kinder Morgan that just completed this pipeline. They're actually not going to be shipping as much gas. In fact, they might be trying to ship the gas out to California. So all these big investments that got made prior to the shale gas revolution, we're finding there's a lot of pipe that's not really needed. Now, while things have been going on up in the Northeast area, of course, here in Texas, we've got the Haynesville, Barnett, the Eagle Ford, which is down closer to the Mexico border. Been a lot of gas coming out of there as well. So what is that trying to do? Well, it can't make its way back up into the north, or not as much can, because we've got Marcellus up there. So they're looking at exports, and we're involved in one of those projects looking at exporting gas. And we're also shipping it down to Mexico. So a complete reorientation of the gas flows in a period of 5 years. The other exciting opportunity, I think, is Cng Lng vehicles. There's probably been more in the news about electric vehicles, and in fact, I think there's probably quite a few charging stations here in the Austin area. My general feeling is that both of them are going to actually evolve. Both of them will probably be growing in niche areas. I think Cng Lng might be useful for very long distance, very predictable routes along interstate highways with trucking. I think electric vehicles are going to be short commute. You know, maybe people up in the Northeast, a lot of people take a train to go into the major cities, and they have a commuter car that takes them to the train station. So short hops where they don't have to go very far, charge their car in their home at night, leave the car at the station, come back. Their round trip commute might be 3 miles, 4 miles, tops 10 miles. I think that's how it's going to evolve. Taxis is another, taxi fleets. I think electric vehicles will probably make their way into taxi fleets. My point on this chart is, though, when you look at both of these, and we're actually looking at both right now, everything leads back to natural gas. You can take the natural gas, you can clean it up, you can distribute it as LNG or CNG, compressed natural gas, and you can run it through a spark ignition engine. Or you can take the natural gas, spark it through a power plant, distribute it, and then charge it into a battery. Either way, it comes back to natural gas. I'm going to skip the benefits. Looking at LNG transportation, a lot of data here. I'm going to go through this real quickly. I think one key point is that the pricing is competitive, as you would expect in order for this to be getting some interest in the communities right now. The challenge is for a company like Gdf Suez to build a storage facility for LNG and to ship this around to customers. We're looking at investments that could be $300 million, and it could take 20 years for us to pay this investment off before we'd actually realize a recovery of the $300 million plus some reasonable profit for taking that risk. But the benefits from that left chart, when you do the math on the savings and what it costs them to buy a more expensive LNG fit truck or car, they can actually pay their investment off in 2 years. So you have a mismatch. We got to bank on a 30-year investment Our consumer gets to bank on a 2-year investment. So you kind of get this challenge right now is, well, how do you get the interests aligned between the user and the producer so that you can actually get the industry to take off? And that's the chicken and egg problem. In the U.S., I'm going to go to the far right chart. In the U.S., we use, in diesel consumption, we use about 3.3 million barrels of diesel fuel a year. It's a pretty big amount. Transportation represents 25% of our U.S. energy demand. So putting a big dent in this and doing it in a way where it's lower carbon helps the environment, but also reduces our dependence on imported products. The 3 segments we're looking at now for LNG transportation, and we're not looking at compressed natural gas, we're looking at LNG, and the reason for that is LNG, when you liquefy it, its energy content is actually, it's about 50% less than a diesel or a gasoline. So that means you don't have to, within the same volume, you can store an almost comparable amount of energy, and you can get almost the same distances. I say almost. But given that, we're looking at LNG in 4 segments here. These 4 segments, so we got long-haul trucking, rail, marine, which would be barges, and I think that's the barge in New York City, and actually compression engines that are used in the exploration and production business out in the fields. If you look at just those 4 segments alone and you add up the total consumption, the TCF is trillion cubic feet, it actually represents about 20% of the U.S.'s current consumption. So it's a huge number. Now, I don't think we're going to get it all, but I think even taking 10% of that could have a big impact for a business, but also for the environment. So what we're actually doing right now, we have a pilot. This is not actually very widely known, so you guys are getting to see something that we have not put out in the press. But I talked about our Everett, Massachusetts LNG facility. That's actually the 2 terminals we have up there. We've actually built this summer a portable storage unit, and that storage unit is to allow LNG trucks to come in. And what they do, actually the picture we're showing here is this portable unit's filling the tank to a truck that's going to ship LNG. But this picture here is actually an LNG tank for a truck being filled from there. So we're actually piloting right now in New England, where we have some facilities, the idea of working with truck fleets to let them do LNG. And we're hopeful in the next couple of months we'll be able to make an announcement around a deal that we might possibly sign with a trucking fleet, pretty big trucking fleet up in the Northeast to supply their LNG. So I think that has some promise to it. The challenge is going back to the 30 years for us to make our investment, and this is a pilot plant, but if you look at a large-scale plant, 30-year, 25-year investment, the payback 2 years, how do you get the alignment? So there is some thought about, can we work with financing firms and do equipment lease and then at least align the investment made on the truck with the investment that we're making. So we're working through that all now. This is very, very new to us right now. So that's a little bit on LNG trucking. One of the other challenges for us as a power generator in the U.S. and for our competitors as well is how do we think about building a power plant that could be $1 billion of investment. And it's a lot of money to build a power plant. And these are long time frame projects. We need to think 30 years out in the future. So we need to look at the factors around the evolution of our markets, and we tend to look at them in 3 areas. What do we think the economic output and growth is in the market? What are the long-term drivers to energy usage? Do we need the power production that we think we need based on historical growth? Where's renewables in this picture? Are they going to be built the same way they were in the past? Is there going to be some breakthrough in renewables to where they don't need subsidies? And I think one area where we're starting to see that is distributed solar. We think is a very promising technology. Fuel. Shale gas right now is the lead fuel. But long term, what does it look like? And then what types of trade-offs are there in technology? And I think for those of you that are interested in public policy, is for society, is how do you think about relying on one single fuel source going into the future, because I think that's where we're heading. We're heading towards a lot more natural gas-fired generation. It's a good thing right now, but down the road, what could that mean for the U.S. if there's some unforeseen incident? So very quickly, the EIA puts this out, Energy Information Administration, part of the Department of Energy. The blue squiggly line shows 3-year rolling average energy growth. So it's an annual growth rate. You can see the trend is coming down. The U.S. has actually made a lot of strides in the last 20 years, a lot of it in industry. I don't think it's yet hit residential and commercial, but in industry certainly made a lot of strides in bringing its energy consumption down. And as a result, the growth year over year has been coming down pretty significantly. And the outlook is that we're probably below 2% energy growth. And if you look back to, in the 1990s, we were sitting at 6%. Year over year, we were consuming 6% more than the prior year. So pretty significant. This is an eye chart to look at. If you could ignore the map off to the right, or to the left, I'm sorry, and look at this series of lines here. What we've plotted, and we've been following this since about 2008, or 2009, I'm sorry. We've been following is the forward price for natural gas. And so what we mean by the forward price is you can actually go to an exchange, it's called NYMEX, and you can look up prices. That you can get quotes for gas delivered in the future. So there's a quote for gas across the 12 months in 2012 as you were looking back at in 2008, 13, 14, and 15. And so that top line is if we were sitting in July 2008, which happened to be right around the peak of natural gas pricing in the U.S., you could get quotes for delivery in 2011 and for delivery this year of just over $9 per MMBTU. That's a unit of energy. So $9 a million BTU. If you fast forward to January of 2009, this is when shale was starting to come into the picture, the whole curve dropped down. So now you can get, for 2012, you can get pricing for about $7.50. Fast forward to January of 2010. This is when shale gas, people really started to say, wow, something's going on. Same year for 2012, we're now at $6.50, and so on. January 2011. Here we are sitting in 2012, and what we have for 2012, half of that is actually real cash-settled prices plus some futures, but we're below $3. And the futures market is suggesting that we're in about a $4 to less than $5 gas range. So literally in the span of 4 years, we've dropped, from $9 down to $4. It's huge. So that's one dynamic that you need to think about, and it's had huge implications for how you generate power. The other challenge is for those companies that have based a lot of their business on renewables, the thing they've always had to contend with is that, and we showed 3 maps here, we've got Canada up in the right. Canada has a lot of wind. It has a lot of wind potential. The problem is that little dotted line, or that circle up at the top, that's thousands of miles from where power is actually generated. So you've got to find a way to get it down there. In the United States, we have abundant wind, of course, here in Texas, and going all the way up into the mid-continent, but that's not where the load is. Same thing with solar. Solar is abundant in the desert Southwest, coming here into Texas. But other than California, there's really not that much of the population. It would be good if you could get the power out to here. So the issue you have with these technologies, and that they'll contend with in the future unless you do something on a distributed basis, is you need the transmission. And also solar, at least utility-size solar, not the stuff you'd put on roofs. It's very expensive to build. So here in Texas, for those of you that follow it, there's a program, I think it's wrapping up, it's called CREZ. And the idea was to be able to bring all of the natural resource that we have in terms of wind up in the Panhandle in West Texas and bring it down into the Austin, the Dallas area, the Houston area. I think it's $6 billion of investment, and it's bringing down 10,000 megawatts of capacity. You don't necessarily see all that. 10,000 megawatts of capacity. It's great. We have all this wind out in West Texas. The problem is when you get to things like grid reliability, for those of you who were here last summer, we actually almost came very close to having a blackout. We were about 4,000 megawatts, within 4,000 megawatts of having a blackout. During that peak period, that 10,000 megawatts of wind, the output of it was only 500 megawatts. So you look at that and you say, well, if we went to the extreme and said we want to be a completely wind-based economy, not that anybody is suggesting that, but if we wanted to be completely wind-based, you would have to have as much wind as we have capacity in all of the types of power generation in Texas in order to reach and meet just that one period of time. So that's a challenge with these intermittent sources of power like wind and solar. I think what will make these things work in the future is, can you marry them up with storage? And we're not there yet. It's something we're watching very closely. But for right now, I think absent the subsidies, it's very difficult to build wind and solar in the U.S. unless it's on a distributed basis. And then what we also look at is the cost of building technology. So the top elevation of all these bars is what you as the consumer would see based on the different types of power generation technology. So the left two bars are Ccgt, that stands for combined cycle power generation technology at $4 gas and $6 gas. And you can see, even with a carbon price, we've put a $40 per ton carbon price in, which is actually very high. The EU carbon trading, I think, is below 10, if I remember. So this is actually a reasonably high carbon price right now. We're sitting below $100 per megawatt hour. You can divide that by 10. That's about 10 cents per kWh for those of you that get an electric bill and look at it. A gas peaker, which is needed during those peak periods, is going to put you at about 120, 130. Coal is up there. Nuclear is actually, without the carbon cost, is actually a little more competitive than coal. Wind is not too bad, but solar doesn't work. So right now, when somebody looks at what are they going to build, they're going to be looking at these two bars to the left, and they're going to say, well, do I believe in $4 gas or $6 gas? Either way, even with a carbon price, which there isn't right now, the U.S. does not have a carbon price, it's still better than any of the other technologies. So the direction is for a lot of companies to look at building gas-fired generation. The other thing, just going back to that other chart, is this is before you put in incremental investment for transmission. You got to remember, for wind and solar, you also had to build, in a lot of cases, you don't have the transmission investments. You got to add another bar for the cost to bring the new transmission to add that incremental capacity. So very quickly, just running through, are renewables viable? I think some of the advantages, some of which we've talked about, zero greenhouse emissions, there's no waste streams that are coming out of renewables, very rapid deployment. You can put a wind farm up usually in 6 months, 6 to 9 months. That's actually very good compared to a gas-fired power plant that can be like 2 years. But it depends on the states and if they want to keep doing this. Some of the challenges, we talked about the transmission linkages. Costs have decreased, but they still require subsidies. One area that actually is coming close to what we call grid parity is solar, rooftop solar. It's actually getting very competitive, and I think it's an area of development in the next couple of years. But it requires a lot of tracts of land. If you're going to build a big solar farm or a big wind farm, you need thousands of acres. Coal, dirty coal. Advantages, we have a lot of coal in this country. Now you've probably heard the words, the Saudi Arabia of coal. We really do have a lot of coal reserves. So from a national security, from an energy security perspective, there's a lot of benefit to coal. It's also very inexpensive, excluding the externalities of carbon and the impact on the environment. But from an ability to take it out and ship it, the infrastructure is there. It's easy to run. It's very reliable. All the transportation is there, and it's a proven technology. The disadvantage is, of course, air pollution, ash disposal. The cost is going to be going up with a lot of these new environmental issues. And what we'd like to see, and we are participating in this, is can we get carbon capture and sequestration or integrated gasification combined cycle? Can we get these technologies that actually can allow you to get your emissions down to a combined cycle plant or below? I think there's a lot more work to do on that, but I think that's the savior for coal. And hopefully there's going to be a breakthrough in that. Nuclear. You know, with Fukushima, big question. Germany is looking at shutting down its nuclear power plants. France is even looking at shutting down its nuclear power plants. Japan, of course, said they wanted to shut down all their power plants. But what do you supplement it with? Nuclear is actually a very reliable fuel. Base load, very large plants, zero emissions. It's a meaningful source of supply diversification. I think that's very important for a society. But we have the challenges, very capital intensive. Building these plants, $5, $6, $7 billion, and a lot of times there's cost overruns. So it costs consumers. High fixed costs, of course there's the security risks, and then of course the NIMBY, not in my backyard. Nobody wants to be looking at one of these sites. Nobody wants to deal with what do you do with all the waste. So it really leads us to natural gas. And we think for right now, for the next 10 years, natural gas-fired generation is it. Now, just for those of you that are not familiar with the technology, I've been saying the word Ccgt, combined cycle gas turbine. What it is down here you have a gas turbine, which is effectively a jet engine, a stationary jet engine. You burn gas, you compress the gas, you burn it, it expands the turbine, drives a shaft, generates electricity. The hot exhaust, and you take about whatever you put in as energy, about 40% of that comes out as useful power. You take that exhaust, you run it through actually these big tubes up here, and you boil water. The water boils, the steam turns a steam turbine, and about 40% of that gets recovered and turned into power. So the overall thermal efficiency of one of these plants is about 60%. It's actually, I think 61% is state-of-the-art right now. GE's got a plant that does that. Very low emissions. You can do a lot of these without a lot of impact on water consumption. Very reliable, very fast response. You can use these with renewables. So this is considered state-of-the-art. And with shale gas, it's very inexpensive, rapid deployment compared to some of the larger technologies. And then we've talked about CO2 emissions, half the CO2 emissions of a coal plant. The challenge right now, though, is with, at least in the U.S., is we have a lot of gas that's not quite ready to get to the market. There's new pipelines that had to be built. That map that I showed you with the gas, the new gas flows, the pipelines are not there to take the gas to the southeast. So getting gas to build new plants is still a challenge. And I think the jury is still out on hydraulic fracturing, fracking. Is it really dangerous? We've seen reports that suggest it's not dangerous. There's some other reports that have come out that suggest otherwise. I think the jury's still out on that. And I think it's up to the industry to police itself and make sure it does this in a responsible way. The other issue historically is natural gas prices are extremely volatile. And that makes it very difficult for a power generator because they need to figure out how do they lock in a price so that they can get a reasonable price to their consumers. So what are we doing in North America? Well, we have 13 gigawatts of capacity, 13,000 megawatts of capacity. Roughly 60% of it is this gas turbine combined cycle technology, the state-of-the-art technology. We also have hydro, biomass, wind, and solar. We have a little bit of coal. We actually have one coal plant here in South Texas. And then we have some natural gas oil peaking units that in this environment are effectively natural gas. So predominantly very clean fleet. What are we building? Well, in the U.S., for those of you that follow or just follow what's going on in the power markets, and if you don't, that's fine. But given the economic recession, we never fully recovered to the demand levels that we were prior to the recession. And there was a lot of power plants that were built in the early part of the last decade. So as a result, there's a lot of additional capacity. Texas is the exception. Texas is actually, we think in about 2 years, is going to run out of capacity, 2 to 3 years roughly. But what we've been doing in the interim is we've been expanding some of our plants to help anticipate the shortfall that will exist in the Texas market. And we've also built a solar farm, believe it or not, in all places, Massachusetts, where there's not that much sunshine. But they have a very attractive state policy that pays us to build a solar farm. So we've built a solar farm actually right on top of one of our hydro facilities. So overall, a very limited new build in the U.S. Mexico. Mexico is a huge opportunity. I'm going to have a slide that shows some of the needs that they have in that country. We've gone over? Okay. Let me go through this real quickly. Mexico, we're mostly doing gas-fired generation. And then in Canada, we're doing a lot of renewables. So I had said earlier, why are we doing renewables in Canada? Well, the province of Ontario made a decision that they were going to shut down all of their coal, and they also said that they were going to supplement those who built solar and wind farms with a very high price, much higher than some of those curves or the bars that I was showing earlier. And as a result, we said, this is an opportunity for us from a business perspective to build these facilities, and this is what the community wants. This is what that province wants. So we're building wind farms and solar farms. We have about almost 1,000 megawatts, pretty significant. We're about a number 4 player in Canada, and we're going to continue building more. But that's what that society has decided to do. They want to pay a premium, and they're paying more for their power because of the solar and the wind, and we're there to build it. I'm going to skip Mexico other than to say huge opportunity for the United States to actually build, and we're there in a pretty big way looking at ways to build gas pipeline infrastructure and power generation, both for the government but as well for industry. And I'm going to skip this, and since I've run way over my allotment, I'm going to leave it open to questions for whatever time we have left. Please.
Can you tell a little more about? If you could wait for just 1 second, we have to have you wait for the microphone to get for the video. 1 second. Yes. Well, I'm not sure it works. Oh, it's fine. Can you tell us a little more about the ancillary? Mark, you mentioned those a couple of times, and I'm not. Can you?
Sure. So. As a retailer, what you need to do when you go to talk to a customer is you need to figure out how are they using power across the hour, because right now electricity can't be stored. So I need to figure out, say for this building, what is this building going to use at 6 p.m., what is it going to use at 6 a.m., what is it going to use 3 in the morning? And I need to build a shape. I need to say, you know, at 6 a.m. I'm going to use this amount, and you come up with this, we call it the wedding cake, but you basically have this hump. And in that hump, we call the block part of it the 7 by 24. There's a minimum amount of power that this building will use. Even if all the lights are out, there's a minimum amount. And so what we do is we go out and we'll contract for power that will supply it 7 by 24. And then there's another peak or another piece that we buy from intermediate units, and we go out and contract for that. That's another block. And then there's contingencies that, you know, if the temperature in Austin goes to 110 and an air conditioning unit goes out, not goes out, but, you know, there's some problem where it's not running as efficiently and maybe there's some, you know, additional power consumption, we need to plan for that contingency. So we'll go in and we'll buy additional capacity. Now what the grid operator does as well is they need to have these ancillary products to make sure that the grid is always functioning, it's always holding to a constant voltage. So they buy what's called spinning and non-spinning. They buy fast start, there's voltage, there's regulation, there's all these products, and essentially the power plants themselves decide what kind of product do they want to offer to the ISO being who's operating this grid, and those are the ancillary components. So it could be, I'm going to have a power generator that if the voltage drops 1 volt, I'm going to bring my power in and get the voltage back up. Another ancillary might be if a coal plant trips, 1,000 megawatts trips, I'm going to bring my unit in 15 minutes, and I'm going to run for 4 hours. So a lot of contingency planning, all of this because you can't store the power. And it's a massive challenge. Again, you think, you know, just keep the lights on. It's a massive challenge behind the scenes to always have the power on and at the right frequency and voltage. Yes?
Hi, thank you for the talk, very, very instructive. So my question, I have many questions, but to pick one in particular, when you showed this slide about the cost of production for megawatt hour, so there was an item that is about the cost of CO2.
Yes.
So that is the cost of reducing the CO2 to zero, or what that represents?
No, what this represents is we think about at some point, and 4 years ago there was talk about having a carbon market, so there would be a price on the emissions of carbon, and the price was in dollars per ton. So that might revive itself again. I think for right now, it's, you know, given the political climate, it's not going to happen. Actually, California has implemented this carbon trading market, but what it allows people to do is it lets the market figure out what's the best way to reduce carbon emissions. And so what comes out of that is you have buyers and sellers of these carbon trading units, and these carbon trading units are priced on $1 per ton. So we said if the carbon trading units are priced at $40 per ton, based on how much a power plant emits, that's how much additional, those black bars, the black elevations represent how much additional costs there would be to run that plant.
How is the experience of Europe with these carbon
Credits?
Yeah.
I can speak to, there's actually another market in the U.S. It's called RGGI, and it's the regional greenhouse gas emissions or industry, I think. It's basically the New England states and New Jersey and New York. The problem they're having there is they've issued a certain number of credits that can then trade into the market. The credits are trading at $1 a ton, half a dollar a ton. It's irrelevant. I mean, essentially those black lines go away. So what that means is when you're running your plants real time, coal plant, gas plant, and I have a 50-cent per ton carbon cost, it doesn't matter. I'm going to pick whatever fuel is cheaper, not carbon. The carbon cost is not going to push me towards gas. So that's the knock on it right now, is that there's too many credits, too low of a price. It's not really driving a retirement or a shift towards gas. Actually, the shift towards gas is happening because gas is so cheap. It has nothing to do with the carbon market. I can't really speak for what's going on in Europe other than I know the price is pretty low. I think the challenge they have right now, from what I've read a little bit, is given where the economy is at, you know, with the euro situation, I think they're looking at, you know, can we really afford right now to have this thing operate at the really high costs? Because, you know, they're talking about $50, $75 per ton carbon costs. That puts all of the fossil fuel generation completely out of the picture. But the other problem is it subjects industry and society to very high prices.
Hi, how's it going? Thanks a lot. I was wondering if you could speak really quickly to commodity and supply risk, especially as it relates to what you call the 10-year gas market, and specifically how that relates to the longer payoffs usually associated with generation capacity.
So on the commodity risk, I guess there's two ways to think about it. We operate merchant plants and we operate contracted plants. On the merchant plants, what we mean by that is we actually don't build them anymore. But we'll put $1 billion in the ground. You know, that picture I was showing earlier, we'll put $1 billion in the ground, we'll connect it into the grid, and we got a bunch of guys in Houston that say, all right, I'm going to follow the power price, and if power goes to this level, I'm going to buy some gas, I'm going to burn it in my machine, and I'm going to submit a bid in, and hopefully get called, and I sell my power. And to do all of that, you've got to manage the price. You've got to lock in a price for your power, you've got to lock in a price for your gas so you can make a profit, right? Otherwise, you don't have business. So that's a big issue, and if you don't get the supply part right, or you get it backwards, and you get hit with charges for, you know, imbalance charges, which are around getting the gas to the plant at the right time, you can end up being upside down, meaning you've paid more for your gas than what you got for your power plant. So that's the commodity risk. Now, there are other plants that we operate in other parts of the world where that's not there. What happens is, I agree, I'm going to build a power plant, and I agree with the government, I'm going to sell power at 15 cents a kWh. And the government's going to give me power, they're going to give me fuel, they're going to give me gas at 8 cents a kWh, and all I have to do is operate the plant. So my job is to make sure the plant is always running, And when it's needed, it's there, and there's no trips and no hiccups. And that's a different model. You don't really need commodity management in that view. But what we have in the U.S. and in Texas is a merchant market. So there are actually generators out there. They're building plants, running these plants in the hopes that they'll make a profit.
Nice.
Sure.
Just one more question. Dave, can you pass the mic?
So Chair in Houston, first of all, thank you. Very informative. Wish we had more time. Do you think that we'll have a lot of nat gas construction coming online in Texas, despite the hesitation of having a capacity market? When you read the Brattle report for resource adequacy in ERCOT, it's amazingly low nat gas prices, wind, no demand response with the capacity only market, no capacity market. So it's encouraging to see you're investing in that. So do you think we'll go to a capacity market, or do you think raising the offer cap enough will encourage more suppliers, IPPs like you all, to come in and then meet our resource adequacy needs?
Yeah. I probably could answer it two ways. I think one is the one data point we have is Panda Energy. For those of you that follow this, Panda Energy just announced they're building a 750 megawatt combined cycle plant, state-of-the-art power plant, actually not far from here. They got financing. Typically when you get financing, you put your own money in, and then the bank lends you money, just like when you buy a house, you get a mortgage. Well, you get a mortgage for the power plant, and typically, historically, it's been 70% of the cost of the plant the banks would lend. Turns out in this situation it was 40%. And they lent at a very, very high interest rate, 10%. And they only lent for 6 years. So we looked at that and we said, all right, we'll look at the cost of what it takes to build that power plant. We'll look at the cost of their financing. And we said, we don't know how the people who put their own money into it, who own the plant, how they're going to make money. Because the market, the forward prices on the market don't justify building a power plant. So I think the market is saying right now, nobody rationally should be building power plants. The price signal's not up high enough. So what'll fix that? I think in the interim, you're going to need to have an immediate signal to the market to say prices are up, prices are staying up, we're committed to prices being up, and it's not about egregious profits, it's around a reasonable return on billion-dollar investments that are needed to keep our economy running. And then at some point, I think maybe that can be transitioned to a capacity market. I think either one can work. I know there's a school out there that says, let's take this capacity mechanism that's used in other parts of the country and bring it into Texas. I think Texas is saying, look, we've got our pride, we've got a market that works, let's tweak it, but let's not go to a capacity payment. Either one works, or can work.